Thanks. Can you hear me? Yeah, okay. Okay, so yeah, thanks for coming. Before we dive into the details, a few words about us. So I'm Johan Mabille. I'm a technical director at Quantstack. Some of you may know me as a contributor to the Jupyter and the Mamba ecosystem. And Alexis here with me is a software engineer. He joined Quantstack 2 years ago and is mostly working on the Apache Arrow ecosystem. And today we're going to talk about a new beast in this ecosystem called Sparrow. So the first thing is, why did we develop Sparrow? So Apache's Arrow tabular format has become a de facto standard. So now it is widely adopted in the ecosystem, but it has some drawbacks. I don't want to create any polemics here. It's just like, yeah, so yeah, it's a huge monorepo with a lot of dependencies. And some of the projects want to only exchange data between like different data frames libraries. So they may not want to trigger everything from Apache Arrow, like computation kernels, Sparrow IPC, and things like that. Another drawback, I mean, which we have in 10 years probably in Sparrow, is that Apache Arrow was started like more than 10 years ago. And in the meantime, C++ standard committee released a new version of the language that brought new features really, really awesome for array implementations. And we thought it would be a good thing to leverage that in a fresh and modern project. So what is Sparrow? It's exactly that. It's an idiomatic C++20 implementation of the Apache Arrow memory format, featuring many things. We're in C++, so firstly, value semantics, ranges and iterators. So ranges is a new feature from C++20. It supports both typed and untyped arrays. So that's something like, well, when you're used to doing some C++ computation, you like to have to know the types and not do dispatch all the time. But sometimes you have to for dynamic plugging in other systems, in Python, for instance, or other languages. So you need both features. Contrary to the Apache Arrow, we support mutability, so only for typed arrays, because it just makes you closer to the usual experience with std vector or std array. We also provide convenient constructors and builders for easy usage, so you don't have to like write a lot of code to instantiate your arrays. And last but not least, it provides like really nice built-in formatters, which is the new features for C++20 also, like the ranges. So some properties about the project. So first, it has 0 dependencies. Unless if you build it with libc++, because, well, it's C++ and some compilers are not exactly conformant to the standard. It passes all Apache Arrow integration tests. It's compatible with version 1.0 to 1.5, so meaning you can use it in production. It's packaged for Conda, Conan, Fedora, and VCPKG, so it's easy to get it. And it's licensed under the Apache license, so just like the original project. And now I will leave it to Alexis for some demo.
Thank you. So we'll switch to Jupyter Lab with XUCPP. Okay. Okay. So we are running all the demo through Jupyter Lab, and we'll start with Sparrow Nullable. So Sparrow Nullable is a kind of std optional. But we can keep references on some elements. So let's start here where I define a basic one. Okay, and by default, it's null. Second one, we define an integer, and okay, it's fine. So we have several ways to create a nullable. Here, we use the make nullable, and as we said previously, it's like a std optional, so with extra features. So we only can have a reference. Here, in this case, it's not a reference. We keep the value inside. So when we try to get the value, okay, we still have the value even if it's null. So we have the value or like std optional, and we can change the validity of the elements just by changing the flag. Okay, nice. So here another example with a reference, and we can change the validity to Okay, so here it's std nullable, a Sparrow nullable. It will be used in the next classes. I mean, in the classes in the layouts of Sparrow when you try to get elements with the brackets with adds. We'll see that later. So next, continue with the construction of a primitive array. So here it's really simple. We can just pass a vector of int and a vector of bool for the validity, and that's it. We have our primitive array. We can also pass a name, metadata. So here we just have a name, and that's it. Let's continue. So we try to ease the development and provide a method like we have in the std, like for the std vector. So we have the name, but we provide the size, front, back, operators, and also the @ So everything is very smooth to write. We provide the std format. So it's easy also to debug if you need, or just show in the log. If you need to have a direct access to the ranges of elements, you can just call values or the bitmap. And yeah, that's it. For performance reason, instead of just using the bracket operator @ which will return the new labels, you should use higher values. It will return a range to the elements. So it will be better for primitives, for fixed size binaries, this kind of stuff. Okay. Also, we want to provide mutability to the layout. So here we just want to change the element. Okay. We can also change the validity, and I mean both. We want to change the element and the validity. And as you can see, okay, we change null, and inside we also change the element, which is 7. We provide a pushback. We provide also a popback, like for std vector. We can insert the values. So in this case, you have to provide a label. And you can also resize the layout, I mean the array too. Yeah. In some case, for security reason, for confidentiality, you don't want to let the element, even if they are nulls, we keep the value in the memory. So if you want to erase element, we provide the 0 null values, and in that case, you can see that okay, already the element is now to 0. Is set to 0 when it's null. About slicing, we provide methods too. So we can just really copy the primitive with a slice, or just have a view, a new view on the array. And about the record batches, so it's also really simple. So here we create 2 array, a primitive array with int, and another one with a string. Then we move them inside the vector, and we pass the vector to the record batch. So with a name, we can also pass metadata if you want. And boom, sorry, I have to click on this one. Yeah, so we return the number of columns, number of rows. You can also print it with a std format, and you have a nice table. Things like that. So it's really simple for the moment, but at least it's easy to debug it, to show in the log. If you don't really know which type of layout of array you need for your data, we provide also builders. So what you just have is to pass a vector. For example, here it's a vector of float, and you put it inside a build, Sparrow build. Okay, I have to include, sorry, the header first. And then, okay, I created my array, and as you can see, automatically it will create a primitive array with a float. Here, let's take another example with an array of float. And so in that case, it will create a fixed size list, and everything is smooth. Okay, so now I will switch to another version of XUS CPP in the light version. So in that case, now we are directly in the browser. I mean, we compile in the browser, and it works too. So here about the interoperability with our data interface. So from the Sparrow classes, you can extract the arrow schema and the arrow array to pass to another library. So you can just get the pointers. You can also get the structures. And in the so if you have some pointers or structures from a third library, you can pass it to Sparrow array. In that case, you don't really know maybe which type of array it is, and so we do it for you. So here it's an integer, okay, and so it's as it's untyped, you can't directly call method on it, so you have to visit it. And here, also we already know that it's primitive, so we only implement this part. So we'll try to print all the values in the visitor. Okay, nice. If you want to access with the element with brackets or the at, it will return a variant, and so you have to call stdget on it and do what you want to visit. And that's it for the demo part.
Thank you. So this was run on the CPP, which now provides a C++ kernel in Wasm. So I heard two cool guys present that tomorrow, so do not hesitate to go to their talk. Right. So let's talk about some architecture of Sparrow. So the idea was to make something really simple with well-isolated layers, one from the other. So first, we have low-level primitives. So maybe low level is a bit too much because the new label is something we'll see in the API, but for the other buffer allocators, dynamic bit set, they will be buried down Sparrow. You should not interact with them directly. I won't go back to nullable because Alexis already gave a lot of detail about it. Yeah, just a few words about nullable. The main difference with optional is that it can hold references, which is not the case for optional. And also, when you have an optional and you set it to null, it will destroy its value internally, while it's not the case with nullable. That was like shown in the demonstration just before. Yeah, the other one we don't really care. Then we have the arrow interface. So this one is built upon the low-level primitives, and it's basically they have wrappers around the C data interface from Apache Arrow. And they provide two modes. The one mode, I mean maybe three modes, sorry. The one mode is like, it's a view. So in that case, you don't have mutability or resizing, of course, because you don't know how it was allocated. We have the case where we own the data, so we instantiate the C data interface from the builders or the constructor of the types array that you've shown before. And the last mode that we are developing, and it's still a bit buggy, is the shared mode, so which is like the memory model from Apache Arrow. On top of this layer, we have the type arrays. So a few words about them. It's a like kind of complicated multi-layer CRTP architecture. So the idea, we have one array class per layout. So it's more than 10 layouts plus variations. We have two kinds of layouts, so nested and non-nested. So nested like integer, floats, strings. That's non-nested, sorry. And for the nested ones, we have the list, the structure, the map, etc. So I guess you all know that if you're using Apache Arrow. And the idea is that all these type of arrays should provide almost the same API. So we have some exceptions, thanks to dictionary array. But except from that, it's the same API behind. The way we implement that, so when you think about it, the only specific part of a layout is the way you access the data. So basically the brackets operator. All the other methods, so the front, back, at, even iterating if you want to implement it, they can all be based on this specific operator. So what we do, we capture all the common implementation into CRTP-based classes, and they just rely on the implementation of the specific operator into each of the layouts. For the user of Sparrow, this is transparent. Usually we'll only use the most inheriting classes, so basically the layout classes. And then to make the bridge between typed arrays and untyped arrays, we have a layer of type erasure. So how it works, it's like a classical pattern in C++. So we have like regular interface with virtual methods, which is not implemented, which are not implemented, and then we have wrapper implementation generating from this class, templated by the layout you want to abstract and whose type you want to raise, and you will use that in Placet. And the Placet here, it's basically the array class here, so the array API. And so this one is so the type erasure layer, you don't deal with it. It's like hidden behind the array public API. And the last pieces of this API that are not listed here, so there is the record batch that was shown in the demonstration before. And there are additional methods for convenience, so you can just like read, extract. You can even call dispatch free method. So if you want to apply a function on your array, just like write lambda or whatever, you pass it to the dispatch function and it will retrieve the right layout type. So that's it for the architecture. Now, what's next? So many things. First one is align allocations. So for now, implementations in progress means we've wrote it, but it's buggy, so we're trying to make it work, especially on Windows. Mutability is not totally done, so it works for non-nested layouts, but we have to do it for structs, list, etc. Another one, another thing that will come is Sparrow IPC. So it's another package. It will not be into Sparrow core. It will be because we want to follow the Unix philosophy, so small packages doing just one thing. So this one is under development. Probably, so it's more uncertain, but if we get funding for that, probably Sparrow tables. And maybe computation kernels in like further future. That's just like hypothesis. A few words about the contributors, because actually it's not just the two of us. So there are more people at Quantstack contributing to Sparrow and Sparrow IPC. And we also thanks a lot Antoine for his help and also question about Apache Arrow. So sorry, you're not on the slide. Well, so yeah, and some resources. So yeah, Apache Arrow specification. I guess you know where it is. So where you can find Sparrow. And the documentation, so this documentation includes a deployment of Jupyter Lite, so you can test Sparrow online without installing anything. And I think I'm a bit in advance, so that it's time for questions. Thanks.
Any questions?
Thanks for the great presentation. This is going to be a very self-interested question, but what's the status of the IPC implementation?
So currently, we have implemented serialization and deserialization for most of the layouts. And for more advanced details, I will pass it to Alexis because he's actually doing the work.
So for Sparrow IPC, so for the deserialization, we are almost okay. For the serialization too, but so it's really the first steps. We have to improve it, like for the serializer interfaces. But I don't know, maybe in 1 or 2 months we can release a version.
Thank you.
For the IPC, if you're aiming 0 dependencies, are you writing your own flat buffer library?
No, not for Sparrow IPC. For Sparrow IPC, we have dependencies.
Okay.
Thanks for the talk. There's another project that's part of the core Arrow project called Nano Arrow, which is also a very lightweight C++ implementation. And I'm just curious how, or C implementation. So I guess, yeah, if you could talk just about what the goals of Sparrow are compared to Nano Arrow, if you're familiar with it.
So as you said, the Nano Arrow is it's a C implementation. So really with C++, we try to provide to the developer ranges. I mean, really modern interface. So it's really one of the difference. I think in the implementation we have, I don't think we have. Closed implementation. I mean, every in the core, it's really different. But yeah, I don't know if you want to add something about that.
No, I think it's the most important. Yeah, we just want to bring like some C++-ish API to the C API of Apache Arrow. So yeah, that's the main difference.
I can leave it, Mike.
Come on, we're hungry.
Hi. So I'm curious what the motivation for mutable arrays is. I think you mentioned because it kind of fits the C++ expectations more, but I'm wondering if there's more of a use case beyond that.
But for big data in production, I guess none. It's more for debugging, playing with it when you're prototyping something, like in a notebook. You want to be able to change value and not like recreate your array from start. So yeah, it's more these kind of things. Maybe we'll see some use cases, especially for primitive arrays, because mutability for other arrays is really inefficient. For string arrays, for instance, you have to reallocate the buffer, so it's not, or can provide some batch method to do one allocation and just for many strings you want to insert. But yeah, it's basically not efficient at all. So yeah, it's more for playing with it.
Sounds good. Thank you.
If there are no more questions, then let's thank our speakers again.
Thank you.